Last time on Project E. String, and notice how it's capitalized because it's actually a class that is embedded in Java. Boolean, which can only take on two outcomes, true or false. What will we cover next? Stay tuned in to find out. Hi, I'm Hubbard Cates, and welcome to the last video of the year of Project E. In this video, we're going to cover a variety of topics in computer science. And we're going to start with shorthand assignment statements. Now, of course, you all know the basic assignment statements, plus, minus, equals, times, divided by. But there are also some other assignment statements you need to know if you're studying computer science. First, we have modular division. So you have one number divided by another number. The remainder would be the result you get from modular division. Modular division is represented by a percent sign, and it's very useful for figuring out the change in coins. Unlike other operations which use square root and powers and exponents and stuff, the modular division does not require you to import anything. One thing you need to know when using modular division is that you can never give a decimal value to an int variable. However, you can give a whole number value to a double variable. For example, if you give the value 5 to a double variable, it will come out as 5.0 because it's decimal. Let's talk about unary and binary operations. Unary operations are when one number is required. Binary operations is when two numbers are required. Unary operations would include plus equals, plus plus, minus minus, and exclamation point, which represents not. In the Java order of operations, unary operations always come first, followed by binary operations in a certain order. Multiplication, division, and modular division will be in the second tier of the order of operations for Java, and it will be followed by plus and minus, not to be confused with plus equals and minus equals. One thing you need to know, however, is that every number in Java terminates because computers are finite. For example, if you put in 1/3, you're going to get 0.33333. It's going to be really long, but it is going to end at some point. Also, say a double variable x is given the value 2.9. Now say you want to change x to an int variable. Well, x would not equal 3, but it would equal 2. This is called truncation, where it's rounding down no matter how close it is to the next number. When I said plus plus and minus minus earlier, I'm referring to increment and decrement operators respectively. Increment operators increase the value by 1, decrement operators decrease the value by 1. It's that simple. Next, let's talk about the string class. Now I say it's a string class because string is capitalized, and all classes are capitalized. Now say you have a string variable x, and it says hello. The h is capitalized, there's no spaces, no punctuation, just says hello. So try to look for the length of this variable, you will get 5. This is shown in x.length, and it counts the number of characters in the string. When you're printing something out and you need to use multiple lines, be sure to use \n, which creates a new line. This is much more efficient than saying system.out.println da 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 and then using another line and saying system.out.println da 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 da. You could just use \n to create a new line, all in one line of code. If you want to repeat a command, use \r, which goes to the start of the current line. I really don't use \r as much as \n. \n is a lot more efficient. So you have int x equals 12. If you put the word final before int, then x will always equal 12. It cannot be changed. If it ever is changed, then the compiler will output an error. So final means it can never be changed. Next, let's talk about comments, which the compiler completely ignores. // is on a line by itself, while /* and */ includes a bunch of stuff that the compiler ignores on multiple lines, and it's usually automatically created at the beginning of your code. If you ever look at a flowchart, it's pretty self-explanatory, so I'm just going to simplify this for you. Circle means start, square means a command that will always be done, and diamond is a yes or no thing. It says, is this da 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 da? If yes, then this way. If no, then this way. That's diamond. That's a Boolean operation. Also, parallelogram is calling upon a method. Finally, let's talk about the most important thing in this video realistically, branching and looping mechanisms. These mechanisms are controlled by Boolean operations and include if else, switch, for, do, and while. Let's start with the if statement. It goes something like this. If something is something, that would include a Boolean expression. If this Boolean expression is true, do this command. Else, if it is not true, do this command. This takes up multiple lines of code, and unless your command is one line, you must put in braces. Now say nothing happens when the Boolean expression is false. Well, that's when you omit the else and just have an if mechanism. If this command is true, do this. If it's not true, do nothing. Fun fact, you could also do if-else statements within if-else statements within if-else statements forever. However, it is not very efficient and would be much more efficient using a switch statement, which I will get into. The switch statement implements multi-way branching, which is a lot more efficient than if-else statements. There can be as many branch statements as possible, and all of the branch statements include the word case, which shows that if this variable is 1, then this happens. This variable is 2, this happens, and so on. Now when I said branch statement, I was wrong because they're called case statements. And every case statement ends with the word break, which ends the loop and moves on to the next part of the code. Something you also need to know for if and if-else statements and Boolean expressions is the AND operator, which is ampersand ampersand. Also the OR operator, which is this line. That line is actually called a pipe. I don't know why. Maybe because it looks like a pipe. I don't know. So you can't say 1 is less than x is less than 2. That is an illegal Boolean expression. You have to say 1 is less than x and x is less than 2. Now let's get to loops. All loops should be finite. All of them should end. The Boolean expression in the loop should eventually be false. If it's not false and it's an infinite loop, then your program's probably not going to work. If you know how many times your loop is going to iterate, you should use a for loop. And the for loop goes something like this. First, you declare a variable to be a certain number. You put it in a Boolean expression that keeps the loop going, and you add another expression that changes the variable. For example, if you want to iterate the loop 25 times, do x equals 0, x is less than 25, and x plus plus. If you don't know how many times your loop is going to iterate, you should probably go with a while or do while loop. A do while loop is different from a while loop because a do while loop always iterates at least once. In contrast, a while loop can iterate 0 times. While loops are very simple. Just say, while this Boolean expression is true, run this command, and then go back to the while statement. And if the Boolean expression is still true, run this command again. The Boolean expression will have to eventually be false because otherwise it's an infinite loop, and infinite loops do not do well with Java. Now, remember when I was talking about switch statements and I mentioned the break statement? Well, break statements end the current loop and move on to the next command. However, the continue statement, while pretty similar, it has some differences. Instead of ending the loop, it ends the current loop iteration and it goes back to the Boolean statement of the loop. And then there's the exit statement, and if you put this on the thing and the code gets executed, the entire program ends. Yeah, if you're dealing with loops like this, it's very important to learn how to trace variables. And that's basically recording the value of variables, changing the values of each variable, documenting every single variable in like a grid or chart or whatever. Just make sure you know what the variable values are going to be. Once you master all the things I've talked about, you're probably going to use for loops, if-else statements, and whatnot in basically every single code you're going to do in the future. Now these statements may seem simple, but it's going to be crazy once you really get into the code, once you really get into your final project. It's going to be absolute chaos. You're going to have for loops within your if statements, within your if-else statements, within your while loops, within your switch statements. I'm kind of exaggerating here, but this is kind of based on truth, because most of my programs probably end up like this. Well, in the next episode, it's not going to be as chaotic, but it's still going to be really complicated. This has been Harper Cates, and I will see you next time.
Which subject are we gonna teach next?
Spin the wheel to find out. Next time on Project E!